My name is Jeff Blankenberg, and I am an Alexa evangelist from Amazon. That means that I get to play with all the cool Alexa stuff and learn about it, and then go out and tell everybody else about it, which is a pretty fun gig. And I have the honor of starting off this session to talk about JPL. I'm on stage with a robot. That's pretty awesome, right? So that's all pretty exciting. Now, we have some people funneling in, so I usually like to do something like this once everybody's seated and they have their laptop out and they've spread out, and then I'm going to make everybody move. So the way this is going to work, and if has anyone been in one of my sessions so far this week? A couple of you. I warn you, you're going to have to do this again, so I apologize. But it's 5 o'clock. It's been a long week already for some people, so I'm going to get you guys up and get you moving and excited, and this will take like 3 minutes, I promise, but it's pretty awesome. So the concept is, we're going to start this session with something I call Ultimate Rock, Paper, Scissors. Has anybody played before other than the people that have been in my sessions before? All right, so the way this is going to work, man, there's still a steady flow of people coming in. I don't want them to miss out on this fun. So I'm going to start explaining, and then hopefully they'll all get caught up. So does anyone not know what rock, paper, scissors is? Everybody knows? Okay, awesome. So the way this works is I need everybody that has their laptops or whatever, set it below your chair or under your chair or back in your bag would be ideal. And I need everyone to stand up. There's so much power on a stage, it's great. If I was in the back of the room like, everybody stand up, you'd look at me like I was crazy. Okay, so the way this works is you are going to turn to one person or the other, I don't care who it is, but you're going to pick a person near you, and you're going to play one game of rock, paper, scissors. So you're going to go rock, paper, scissors, shoot. Remember, there's 4 steps: rock, paper, scissors, then shoot. A lot of people get confused on that. And you're either going to do rock, paper, or scissors, and you're going to decide who the winner is, and if you tie, go again. And if you lose your competition, you become the person that beat you. You become their biggest fan of all time. Applause, cheering, rooting for them. The person that beat you, the winner, is going to find the next nearest winner to them, and they're going to play. And then they're going to start growing an army of people that are really excited about them being the winner of rock, paper, scissors. All right? And we're going to continue. This takes like 3 minutes no matter how many people are in the room. But once we finish that entire thing, we're going to end up with 2 people left. Just keep playing and keep playing. I want to keep the room separated, though, so don't cross this aisle. We'll have one winner come from this side and one winner come from this side. And then I'm going to bring those 2 people up on stage, and we're going to have the whole room ready for the finale, all right? So that's how this is going to work. So for the next 3 minutes, go. Find someone else. All right, who do we have left? Nice. All right. How many winners do we have left? If there's 2 next to each other, they should be playing. All right. You're the winner of this half? Congratulations. Come on up. Who's the winner of this half? This guy. All right. I thought you were going to bring the lucky bag up, no? All right. So this has got to be a friendly fight. All right? Okay. This is the finale. You guys ready? We have a winner! Congratulations. All right. Everybody's a little more awake. Everybody's made a few new friends. It's not that weird guy sitting next to you. It's the guy you beat in rock, paper, scissors, right? All right. So a little bit about our agenda, what we're going to talk about today. I was supposed to say Amazon Alexa slides. I didn't actually correct that. I apologize. But then we're going to have the JPL guys come up and talk about what they're doing with Alexa. And then they're going to take some questions. So we've actually built in some time at the end to ask questions about all the cool stuff that they're going to show you in a minute. So how many of you, before you got your dots when you got here, had an Alexa device in your house? Oh, that's so cool. Awesome. So for those of you that don't know, we've probably mentioned this a few times, voice, our goal at Amazon is to put voice everywhere. Now you'll notice I don't say Alexa everywhere. I'm saying voice is going to be everywhere. You guys see this growing very quickly in the industry, and I want to make sure that you guys are aware that we're really thinking about this in a very significant way. Voice will be everywhere. We already see it in a lot of places, right? If we think about the first place we put our Echo was in the kitchen to set timers and to listen to music and to do all that fun kind of stuff. You're going to end up seeing it in places like your car, right? Voice is in our cars today. How many people love the voice experience in their cars today? Not a whole lot of hands. We want to help fix that, right? In addition, we see things like the office and in homes where, I don't know if you guys can see the panel on the wall there, but that's a device called Nucleus. That's a device that they took what we call the Alexa voice service and pushed that onto their own hardware, and now they have a home monitoring system that also has intercom and all sorts of other stuff with Alexa baked right into it. This is what we talk about when we mean voice is everywhere. It literally, you should be able to walk up to a vending machine and say, Alexa, give me a Coke, or at least give me a Coke, right? So as we think about the wearable market, right, all the things that are going on there, we have 45 million homes, we have $20 billion a year in wearables, there's 60 million cars on the road. This is a huge, huge opportunity to take all the cool stuff that we get to do with voice and put it on every single device we can imagine. Not in the annoying way that I think you may have just pictured it, but in the way that makes a lot of sense. It's so much easier to talk to a device. I think back to the first time that I gave my grandmother a computer. She was about 75 when I first had the means to give someone a computer, and I got her a computer. She'd never had one in her entire life. And I set it up, right? It was a very gray-looking monitor, and it had a mouse and a keyboard. And I brought up Windows, and I said, click on that menu, and I can show you your apps. And she reached out, and she touched the screen. This was in 1984, right? She touched the screen because that felt like when I said, click on the thing, that's what she thought I meant. But the most natural interaction we have with anything from the time we're a year and a half old is to ask for stuff or to talk to our parents or to interact in a number of ways. And this is becoming the next level of how we're going to interact with our devices. It just makes sense. So for those of you that haven't seen Alexa, I just have to cover off a little bit on the devices that it's available on. We have the Dot, the Tap, and the Echo. It's also on the Fire TV. It's also on Kindle devices, the Kindle Fires. And we're trying to grow that as much as we can, not only within our own product lines, but of course with anyone else that's building products as well. So for those of you that didn't come to some of my sessions this week, we did a bunch of workshops and boot camps on building Alexa skills. I just want to let you guys know how easy this is because it's mind-blowingly simple to pull some of this stuff off. So as we think about what Alexa is, we have this cloud in the middle that is Alexa. We have Alexa voice service. This is the thing that you can put on if you're making a refrigerator or a toaster or a car and you want to include Alexa in that device. That's what the Alexa voice service is. This is all free software that you can take open source and put it into your device if you'd like. The Alexa Skills Kit is what you use to build skills for Alexa. And if you have a mobile phone in your pocket with apps on it, think of a skill like an app. It's the same kind of concept, right? I have the core functionality that Alexa offers me, but I also want to be able to order pizzas from Domino's. And to do that, I need to have the Domino's skill enabled on my device. So to do all of this, what ends up happening is you build a small set of text utterances, the things that people might say to Alexa to make your thing happen. And all of those utterances are mapped directly to methods that live on your service someplace. Any server you want to have, or an AWS Lambda, however you want to set it up, is very, very easy. But it makes it so that you can easily craft a skill that allows someone to play a trivia game, or order pizzas from Domino's, or order a car from Uber, or whatever your business happens to do. We've had some really cool pitch contests during our events this week, and there's been just some amazing ideas. There was one that I'll share with you where the woman was recommending that we put a dot in every conference room in her building. She said there's never a conference room available, but you'll walk down a hall, and she'll say, the room's empty. I want to go use the room. So she walks in and says, who's got this room reserved, Alexa? And she goes, oh, Steve from marketing has this room reserved, and he's not using it. So I'm just going to sit here until he kicks me out. Or it might say, hey, this room's available, and she can go, okay, book it for me. And she gives her user ID, and boom, all of a sudden now we have that room reserved for ourselves, right? That's way easier than like opening your phone or cracking your laptop open and finding that room in Outlook and doing all, it's a nightmare. So those kinds of things, those kinds of ideas are absolutely powerful. And if you have an idea for how you want to talk to a device or a thing you want your voice to be able to do, the Alexa Skills Kit is what does that. So finally, as we talk about devices, we want this stuff. When you say Alexa, we want that to happen, right? We want your car or your phone or your alarm clock or your light bulb to be able to do the thing you want it to do without having to think some contrived statement or figure out exactly how to make that stuff work or have to open your phone or your computer to make all these things happen. So with that being said, as we think about controlling things with our voice and making cool devices do cool things, I now have the distinct honor of bringing JPL up on stage, and they are going to talk to you guys about how they're doing this stuff with their robot. JPL?
So,
thank you.
we're going to try to. We don't have our Echo with us, so we're going to try to use Echo Sim.
Okay.
So we're going to be needing to plug in.
Oh, I think they have an audio cable. I'll tell them that's
So while we're
staged.
setting up, has anybody ever done a live demo? Raise your hands if you have. All right, good. Then you have some sympathy. So we forgot to configure the Echo. So we're faking it on the fly. We're going to use the computer Echo Sim. Anybody used Echo Sim before? Raise your hands if you have. Well, I promise it's exactly the same as using an Echo, using Alexa. So what we're going to do is I'm going to go through some slides while Mick here does the magic behind the scenes. How many people work in a company of 1,000 people or more? Raise your hands. Wow, this is great. Because what we want to talk about is, I'm going to go through a little bit, but in the end, it's about how do you take consumer devices and use them in the enterprise? Consumer thinking and use it in the enterprise. One is easier than the other. But that's what we're going to talk about. So JPL is, anybody been to JPL, by the way? A few people? Wow, I'm impressed. One time I asked somebody, okay, do you know about JPL? Yes. It raised his hand. Okay, sir, tell us about JPL. Oh, dude, you make great speakers. Well, that's not us. Although we're going to hear sounds from Mars on the next spacecraft. So we're 5,000 people. We are an enterprise. We're part of NASA, which is an even bigger enterprise. And we work with lots of big companies. And now we work with lots of startups and trying to take those ideas. So our place is in space. We look at JPL and NASA tries to answer the big pictures. Anybody see Hamilton's keynote last night? Anybody? Raise your hands. Okay. I'm not going to go through the same thing, but just the beginning. So these are the big questions. They're questions that apply to all of humanity. It's questions we really care about. Besides for Matt Damon, we haven't found any life on Mars yet, but we think that there's going to be some. So, that's our context. That's what we do. But on the lighter side of the house, how do we do it? So what we've discovered is if you can predict human behavior, that sounds kind of weighty, but it's really not. It really means, what are you going to care about? If you are in the enterprise and I say we're going to make toasters, you're going to say, who cares? So if we can figure out what are the technologies and the things that you care about, then it's things that you will try to use, and it's things that can actually get some momentum. We forecast it, then we prototype it, and this is going to focus on the prototyping and demoing. So this is what we think the human behavior trends are. And I'll explain in a second why those are really the key thing to predict. So as we look at those, we think we get it right. Now for the next 3 years, we run like hell. We try to prototype it, we see if it fits, and if nobody cares, then we drop it. If they care, then we pursue it. It's a very lightweight, very fast, and very effective approach. And conversation UI, on the second to the last line, turns out to be a really important part. And if you look at all what futurists think about, it's the conversation UI. It's not just being able to talk to it, it's having a conversation. And it turns out to be one of the hardest problems in AI. But Alexa, hopefully I'm not, no, she's not awake yet, is a way of getting that started. So what we look at is consumer space, really fast innovation, lots of things. Everybody is a consumer in the enterprise, and they really want to use what they have at home at work. So the disruption here of the enterprise is that they want to use what they have at home at work, and they want to use it now. So what we came up with was a strategy called E4, which is engage and enable everyone and everything. And engage and enable is really about social networking. It's about user interfaces that are not just typing, and it's about things. So everything is Internet of Things. And what is Internet of Things? It's a huge amount of hype. From our perspective, hype is a wonderful thing. Hype drives venture capital drives innovation, and we just sit on the sidelines and we use it and prototype it as fast as we can. And if we can use a consumer device in the enterprise, it's going to cost less, it's going to evolve much faster, and everybody wins. So what we do then is we prototype it. Now, if you look at this, how many combinations are there on this eye chart? Endless combinations. So it's not about having to invent new technology, it's about taking the use case, the problem that we have, and applying those technologies to that use case and see if it works. So when we talked about Alexa, for us, it's really about having a conversation with a room, whether it be a clean room, such as turn the lights down, set the tolerance to tighter, whether it's with a conference room, and we'll show some of that, where you can just tell the conference room to configure yourself for the next Mars mission, and everything just works. It's about talking to, it's about getting questions, and Mick is going to demonstrate some of those things. But what we're thinking about now is the enterprise, which is, Alexa is wonderful in the public space, but how do you use it in your enterprise? And that's really the key here. And then we're going to finish with cute little RhoV here. And RhoV is a copy of the next Mars rover, but it's built with open source components, and Arduino, Raspberry Pi, and some other goodies that we'll talk about. And of course, lots of AWS things. AWS Lambda, AWS IoT, Greengrass, and other things. So let's look at the use case. That's going to be the finish.
Sure.
So what does it look like?
I can take over from here if you don't mind. I don't mean to barge in on you.
No, please do take it, baby. As long as you did your job here.
Yeah, we'll see. So 2 slides ago, Tom was talking about the combinations. You saw that gargantuan grid. How many of you think we live in an age where the pace of innovation is increasing? That's everybody. Would you believe me if I told you that patents over the last 2 and 3 years have been flatlining? They've been decreasing. Not decreasing, but slowing down, right? People aren't coming up with the new building blocks as quickly anymore. The real innovation today is coming from the different combinations of the already existing pieces. And for us at JPL, one of the most important, we think, potential tools for combining all these things is potentially voice and Alexa and some of the related services. So if we step back 1 slide, thank you, and I can actually take this at this point, maybe. Thank you. I'll give it back. No worries. So for number one, as Tom was talking about, we kind of have 3 different use cases right now for Alexa that I'm going to walk through in different steps and show you the use cases for. The first one of those is the querying and the asking. We know that Alexa is fantastic at going out and getting information and giving it back to us very quickly, and not only in the built-in way that you buy an Echo and you can ask it about the weather, but also you can teach it to do new things through the Alexa Skills Kit. And so we've done that at JPL. In addition to, what's the weather, who's the president, settling, bets with somebody about who the artist is, that sort of a thing. We've also taught it at JPL how to get into JPL databases. So at JPL, and we'll show this later, but we have, for instance, an acronyms database. So what does RDO stand for? There are 4,000 acronyms in that database and counting. I haven't met a single person that knows maybe half of them yet, and myself included. So I programmed Alexa to go ahead and get into that database. I'll give it an acronym, and it's going to spit back out the answer so that you can quickly get at that information. And there have been meetings where somebody says, what does that stand for? And we're in my office. I say, Alexa, what does this stand for? And she basically gives me the answer. It's fantastic. So that's the querying and asking level. The next one is the commanding and the telling. So not only is it just a question answer bot, but you can also, through the invocation of Lambda functions, trigger through Alexa different IoT devices, different processes, queries, whatever you want. You can trigger all of that through Alexa and through Alexa-enabled devices. And then thirdly, to give the robots a voice. And that's what we'll see with RhoV just at the very end, as far as using not only the Alexa Skills Kit, which you can use to develop new skills, but then also using the AVS piece that Jeff mentioned. So being able to put Alexa's brain on other devices potentially, and we did that with RhoV. So moving forward right now into the way that we architect some of the network questions at JPL with Alexa. The first piece, we have, and I'm not the only one in the room who this is true for, we have things on our network that we would prefer did not leave our network. And so one of the potential issues that we have with bringing in some of these consumer devices at a rapid pace is we can't put all of those devices through their paces immediately before we attach them to our network. So we need a way to fix that and to work around it. So instead of putting these devices directly on the crown jewels, where some of the devices Nest might spit out some data that we wish they hadn't. We've created a JPL devices network, which has no access whatsoever to our internal network. It only has access to the public internet. So we assume that that network, the JPL devices network, is going to be insecure, and so we therefore attach whatever devices on it we need. If the device gets hacked and it gets information about all the other devices on that network, it's fine by us. We know it's insecure. We assume it's going to be that way. The way that we get the information out, so say with Alexa, I want to be able to query a JPL database, like the acronyms database, right? We still need to be able to do that. Today, what we've been doing is actually using AWS Lambda and AWS IoT to work as a bridge between our JPL network, the JPL devices network, sorry, and the JPL network inside that houses the internal goods, the crown jewels. So what will actually happen through some of these skills, and we'll show this a little bit in detail later too, is if you ask the Echo, for instance, ask OCIO dashboard, how many Macs are there at JPL? What it's actually going to do is through the Lambda function that I've created with the Alexa Skills Kit, it's going to publish a message to AWS IoT on a certain topic that's basically like the is this Alexa asking a question topic. And so she'll basically publish the question to AWS IoT. There's something that sits inside a service that runs inside on our network that's subscribed to that topic. When it sees that something has asked a question, it's going to go and query the databases, collect all the information, aggregate everything, prepare a text response, and then ship it back out to AWS IoT, which then is picked up by the Lambda function, and then ultimately back by the Echo, where it spits out the answer again at the end of the day. At least that's what we hope happens. That's not only true with Echo and Alexa-enabled devices, but also pretty much any other IoT device that we want to put on our network. So we get, this is where the kind of the combinations that we were talking about really start coming into play for us.
So while he showed that architecture slide, it's an architecture slide for Alexa. I want you to visualize another architecture. Data is arguably the most important thing we have. So imagine a data lake in the middle, and then imagine Alexa on the outside trying to get to that data. Now imagine a keyboard, imagine smart glasses, imagine your smart watch. All of those are just new devices trying to get to that data. So you write APIs to get to that data. Then if you can now overlay some artificial intelligence on it, you basically have command of your entire environment. That's an architecture that works. And that's where we're moving towards. As we're prototyping thing after thing after thing, the voice one is really important. but it's one of many. Once you've solved that, the thing in the enterprise that works, if you can do a demo that somebody cares about, you will get the budget to do it in a much bigger way. And that's if you, how many people have a device network today? A few of you. How many people have an incubation network? Few of you. If you can create an incubation network and the network people can do it in a day, once you actually convince them to do it, then you can now put a device on there, make sure it doesn't leak home nest, or do something nasty. And once you know that, now you can move it onto the device network, and it's still insecure, but all the security concerns go away, and you can now really start prototyping. So once we did that, we've seen tremendous uptick in the amount of devices we can use Internet of Things for. So there's lots of information at JPL, and we have the answers, but where are they? Mick mentioned the acronyms. There's 4,000 acronyms. So how do you do that? The first we did was we actually, Mick typed in a few acronyms into the Alexa skill. Now we could demo it and show it. Once we got the people interested who own the data, they said, well, how can we get it? Then we convinced them to write an API, and now we have an API into the data so that we don't actually have the echo of the Alexa, it's just an input into the data. But you got to get started somehow, and that's where that prototyping and demos work. The idea of being able to ask for an acronym or other information when you need it is tremendous, because people get much faster results and they make fewer mistakes. And of course, having a conversational platform is the most important thing of all. And it's probably the hardest, and that's what we continue to prototype. So how do we solve some of these things?
Right. So at least looking at the first one, and we've talked about that just a little bit before, is our JPL Info Skill. I'm going to try and demo it in a moment, but before I do, I'm going to kind of talk to you about what has gone on into the JPL Info Skill. There are sort of 3 different levels of complexity in this JPL Info Skill. The first one is just I hard-coded the answer to a question, right? That's really simple. For instance, how big is JPL? It's just going to spit out an answer. The next level is actually hitting some sort of publicly available page and pulling back some information, but doing it in a way that was intelligent based on our ontology and the words that we use to describe things at JPL. So what I mean by that is if I want to get information about our SWOT satellite, SWOT is spelled S-W-O-T, by the way, in our context, but not everywhere else. So one of the things that we were able to do with Alexa is in the skills kit, you set up these sample utterances and the slots, and some of the slot values are actually the values that she'll be looking for to try and fill in as parameters to your Lambda function. So if I say, for instance, to this JPL Info Skill, give me the information you have about MSL. It's going to look through the list of mission names that I've given it, maybe SWAT included, and actually go out to a jpl.nasa.gov/mission/whatever web page and pull back the information that it has about that. In addition to that, I've given it a couple of other features where you can actually go touch the API that provides the content for those pages. So if you want to say, what's the launch date of Cassini, what's the destination of MSL, she'll go to the same deal, hit the API, and get that information back. So that's the JPL Info Skill a little bit. And then the third level, the very deepest level, is actually getting into some of the JPL databases. And then that's where the architecture that we had talked about before goes in. Can we try and switch the video and audio to the second laptop? Should I do that from here? If not, it's probably okay. What I might be able to do is try it, see if it works, and if it outputs audio to here, then maybe you'll be able to hear it. Open JPL Info. This is taking longer than it usually does. I'm going to try and give the page a refresh, and then if not, we're just going to give up on this. Welcome to live demos. Act impressed or bored or whatever's appropriate. Open JPL Info.
To JPL Info. You can ask me questions about JPL like, how big is JPL? Or, what was the launch date of Cassini?
Could you hear that? Okay.
How big is JPL? This might work, it might not.
JPL speed campus is 177 acres of federal land.
What is the launch date of Cassini? Ask JPL Info what was the launch date of Cassini.
Cassini's launch date is October 15th, 1997.
What does RDO stand for?
Stands for regular day off, 980 work week.
And days during which I'm particularly happy. So that's a little bit of that. Apologize for the whole prototype mess of the way it is, but that's the way that we work, so it's the way that we're going to go.
Just so the way this worked in the beginning, again, that's the important part, I think, for how to infuse it in enterprise. Do something in the skill, then get to the people who own the data. At first, this particular one, we had to screen scrape because they still weren't convinced. But now all of a sudden, they own the data and they get excited about it. How do I get other people to get to my data by speaking to it? And that's when they will write an API. We've done this now for probably 4 or 5 different groups that own different types of data. And once you can demo it, you will get it.
So speaking,
oh yeah, we'll take that.
Yeah. Speaking of of querying and getting JPL information and NASA information, yesterday during the James Hamilton keynote, Tom announced the release of JPL and NASA's NASA Mars Alexa skill. So for those of you who really like keeping up on space or whatever it is, the NASA Mars Alexa skill is available now today. You can be one of the first few people to download it. You can ask all sorts of questions about Mars. Does it have an atmosphere? Is there life there? What are the winds like? What's the temperature? All that kind of thing. And in addition, you can actually get updates for what the real rovers on Mars are doing today. So, you know, we write these things daily. Today, we drilled this sample. We analyzed the sample from yesterday, that sort of thing. All of that is now available through an Alexa skill in your home. So if you're interested in that, definitely check out that the NASA Mars Alexa skill afterwards. Now we're going to move on to the commanding and the telling.
Just before you do,
Yeah.
So the NASA Mars is for the public. The JPL Info is for private. So how do you deploy, has anybody deployed echoes in your enterprise? Okay, we have. And I wanted to talk about that a little bit. What we found was that you have groups of people in your enterprise. So we defined it to have 2 sets of skills. One is JPL-wide, so anybody can ask for a definition of an ORR. For the budget information, that's more sensitive to certain groups. So that same echo will have a second account, or a second, what's the right word? Account. So each echo essentially has 2, the overall and the private to that group. So if you tell it to turn lights on, you don't have to say, turn the lights green in room XYZ. You just say, turn the lights green. And you define what lights are defined in that group. That turned out to be one of those lessons learned. That was a really interesting one. And we worked with Amazon to figure out how to do that. They were very responsive, and that enterprise deployment now works. And it's an interesting way to do it, because now you can deploy echoes, especially now with the dots, to anybody who needs it, because they're fairly inexpensive. It's the data and the update that's expensive, and this way it makes it work. Good.
Sure.
Next one.
Yeah, so talking about the challenges between some of the commanding and the telling, of course, Alexa is not just the answer bot, right? You can also use it to trigger stuff. You can trigger not only turning on the lights, but also maybe more complex actions. We'll see arguably a more complex example of that with the RhoV. And then giving employees at JPL and people in general a more intuitive interface to their devices and to their data. That's what we're really seeking. So I'm a data scientist. I'm trained as a data scientist. And Tom has given me the best definition of a data scientist that I've heard. And it's someone who makes the data tell a story. As simple as it is. For you to be able to interact with your data via voice, because you're looking at the screen, sometimes people are even asking the questions out loud, like just think, okay, so now what about this? Like, it should just listen to you when you're asking those anyways, right? So making that interface much more intuitive. So the way that we've solved that at JPL, for device control, we're looking specifically at Alexa and a couple other solutions as well for like projector and the lights and the clean room crane kind of workflow where, so for instance, at JPL, we support many space missions. Historically, what we've done is each of those missions will need to spin up some of its own hardware. They'll need to take this conference room for the planning. They'll need to take this conference room for any sort of operations type issues that come up. And so you have these kind of segmented mission-specific conference rooms. That's really inefficient. And now that we've taken on more and more work, we're hoping to consolidate some of these into more intelligent spaces. To do that, voice is going to be a key enabler for us. So to be able to walk into a conference room and simply say to the room, Alexa, turn on the lights, or Alexa, configure this room for the Curiosity stand-up meeting. Maybe the projector goes to the right input, the lights go to the setting that you like it, all of that kind of thing. It should be simpler, and we're getting closer now with some of the tools that are coming out to actually making that a reality. In addition, the Alexa solution can give you some sort of chat tool integrations, right? So one of the things that we're playing with at JPL, and I'm not going to play with it there just because it's a whole thing, but is using, so we're playing around with Slack at JPL at an enterprise level. And so we've tied our Echo so this is an Echo that lives in our office and Tom's office, all of that. They share one of these skills call it the Slack skill for us. And you can just from anywhere say, Alexa, tell Slack to send, and give it a message, and it's going to send off that message to one of our channels that all of the developers watch, and we kind of see what people are saying, right? So I've used this, for instance, when I'm about to demo Alexa stuff, to say, Alexa, tell Slack to send, please don't change any of the skills in the next hour, kind of a thing. And so that immediately gets sent, and it shows up on everybody's mobile device and the whole thing. The other piece is suggestions. So this has been a very valuable one for us at JPL, is one of those shared skills that Tom was mentioning is a suggestions skill, purely so that anybody with an Echo at JPL can give a suggestion to some of the developers as to what they wish they could see on the Echo. Because if I come up with one thing, anybody at JPL has probably already thought of that, plus 6 other things that are way better than my idea anyways. So the suggestions skill is one where you can just say to your Echo, Alexa, open suggestions. It'll say, what's your suggestion? You can give it a big, long answer. We should be able to order pizza or something, to JPL from this. That gets logged to a database for us, and then we get notified as well via Slack and a couple other, communications network options that the suggestion has been added.
And how many people use Slack? I'm just curious. So most of you. So you're at home at night, and somebody sends you an email, you don't see it. You get a Slack message, emergency, the servers are down. It shows up on your Apple Watch, and that'll make you get out of the chair to actually look at your smartphone. It's really amazing how when you if you make it convenient, people will do the right thing. And having a conversation is one of the key things. So being able to, for instance, when you get in front of a big, you're going to give a big presentation, people who are very clear-headed and know exactly what to do, they panic because all of a sudden the projector doesn't go on, turn on, turn on. So you could just say, Alexa, turn on the projector, and it turns it on. Or you're in real trouble, you say, Alexa, call the help desk, and it just calls. It's very different than having to log in and type something, and you can have location on it, so all of a sudden they know where you're calling from. It's a completely different way. So we're going to look at an example of that now. This is from our partner Leidos. And by the way, when we do our demos, somebody's standing with an iPhone or an Android videotaping it, and so we're not videographers, so forgive the quality. It's about testing it and seeing what happens.
Do we have audio?
Now, Alexa is turned it on. Set it to our resident computer in this conference room.
But
if I need Alexa to do something different, for instance, go to our Apple TV. Alexa, turn on Apple TV.
Okay.
And she sends the correct commands to switch this over to the Apple TV to enable us for AirPlay connectivity, or if we need to present something here. In addition to being able to switch between the correct inputs, turn off the lights, we can also set this room back to as it was before when we're all done. Alexa, turn off AV.
Okay.
And you'll see that she turns off the projector and turns right back on the lights with all this interaction.
So has anybody done that to your TV at home? Just turn on the TV, turn it off, turn on the lights, turn it off. Most of us are playing with home automation. Is there really a difference between a connected living room and a connected conference room? Not really. It's using consumer devices and how do you get that into the enterprise. But if you start thinking about it that way, so for instance, this is a Harmony remote. and it's tied into Alexa, and more of those things are coming every day. So it's just a matter of really getting started and trying it, and then seeing what happens, and then impacting the vendors to tie it all together. So let's take a look at another.
JPL uses Internet of Things and immersive analytics, this concept we've come up with, to enhance our cybersecurity awareness at JPL. For instance, we have data coming in off of our firewall in real time about where the attacks are coming from, where the traffic is coming from, and using analytics we can decide what's normal, what's abnormal. For instance, we can assign a note on the piano keyboard to each country that traffic is coming in from with representative data, and actually listen to your firewall. You can hear when it speeds up, you can hear when it slows down, you can be navigating away at other pages and still get beginning insights in real time as to the state of your firewall. Another thing that we can do is use consumer devices, smart light bulbs that change colors programmatically or with your phone, so that we can actually look at, for instance, how much traffic is being blocked or let in, and we can actually update the colors of the lights in the room in real time based on our firewall. If I make it some representative random data, you can see, of course, watching the colors of the room change in real time. This is also very powerful because if I'm doing normal work or something else and the colors of the lights in the room change, this is a very obvious indicator that something has occurred and I need to take action.
So we have those lights across JPL, and that's tied to a real firewall. So you can hear it, you can see it, but then once the security guys deal with it, how do they turn it off? They just tell it. Okay, cancel security alert, go to security elevated, things like that. And all of a sudden, it makes it a whole lot simpler. Being able to use all of the senses, being able to hear it, see it, means you don't have to pay attention all the time. You get alerted, and now you know what to do. And that's actually tied to real data. It goes, one time, Mick said, we were doing a demo, he said, "Boy, don't you hear it?" And I said, "No." "Well, that's the point. It stopped playing." And it was a denial of service attack. He switched to that dashboard, saw immediately that we were getting a denial of service attack from a certain country. And he called the Security Operations Center, and they said, "Okay, we're on it." When they fixed it, they reset the lights. So the conversation is really important. Now, the other thing that's important, especially in an enterprise, is the speed of things. I had a hip replacement. I was laid up on board and on drugs. So I sent an email to Mick saying, "I want to hear my firewall." When I come in, he had created it. So it's just playing with it, the toys. So today's toy is tomorrow's tool. So let's take a look at tomorrow's tool. Let's look at RhoV.
Sure. So how many of you, if any, saw the IoT State of the Union this morning, or streamed it, or whatever it was? Okay. I'll try not to use the same jokes for those folks. So this is RhoV, and RhoV was created, we'll set RhoV this way, try and give everybody a chance to see. RhoV was created originally to go out to schools, to go out to museums, she's been to the White House a couple of times, to try and get people excited about space and space exploration. When I was working on some of the NASA Mars and the JPL Info Skills, we brought somebody in who happened to work on this project. I knew nothing of RhoV at the time. She saw the work that we were doing. I could ask a robot for questions about Mars and it could answer me, and she goes, "Can we put that on RhoV? How great would it be to have this in front of a kid, 7th, 8th grade kid, you know, whatever, 7, 8-year-old even, have them ask a question about Mars and have the robot give you an answer back." And through Alexa, that became possible with the announcement of AVS. This demo has evolved a little bit beyond AVS to also start using Amazon Lex. It's all the same backend in the brain, and the skills are built in virtually the same way. So we'll see if RhoV can answer some questions here for us. RhoV? RhoV? How big is Mars?
Mars is about half the size of Earth. Its land area is about that of all of Earth's continents put together.
RhoV?
If you want...
Is there life on Mars?
We do not know yet if life ever existed or currently exists on Mars, or anywhere else besides Earth. The discovery by the Curiosity rover that Mars provided a habitable environment in the past suggests that the conditions for life probably existed at some time in Martian history.
RhoV?
Note:
What is the radius of Mars?
The average radius, distance from its center to its surface, of Mars is 2,107 miles, 3,390 kilometers.
So speaking of the querying, right, all of the database that she's hitting for the questions and the answers is the exact same questions and answers that are available through the NASA Mars skill that you can get at home now. In addition, she'll be able to go out and get the blog posts about what Curiosity actually did today and this week on Mars, which is fantastic too. But RhoV is not just an answering robot, right? So we can use AWS and LEX to actually trigger drive commands as well. RhoV, follow me.
Following.
So now we have a 3D sensor on the front that looks for the closest object in front of it. If I step back, she's going to drive towards me. If I step this way, she'll see that I went over here. Try and step real close. She can tell I didn't shower this morning. It's for her own good here. RhoV, stop driving.
Stopped.
There we go. Thank you. So that was RhoV. I mentioned AWS and LEX, and it's a subtle difference, but it's an important one that I do want to talk about. The first implementation of this was built 100% with your normal out-of-the-box Alexa voice service. And what that kind of means is that it's going to take my audio, it's going to record that into a file, and it's going to ship the whole thing off to a service, which is going to give me back the answer that my Echo would have given. One of the differences, the subtle differences between Alexa voice service and the new service Amazon Lex that was announced this morning is that Lex is sort of like one skill at a time, and it's a one skill at a time flavor of Alexa, the entire service. So the Alexa voice service is supposed to act just like an Alexa device would. So I could say, what's the weather on Earth? And it would tell me that. Who's the president? Read Wikipedia. It's all the normal Alexa stuff. But then I would have to say, you know, open NASA Mars, ask this question kind of a thing. What we wanted to do instead was have just what you're seeing here, RhoV, and then ask the question, right? So with AWS, the way that we had sort of worked around it and hacked around it was I actually recorded my voice saying open NASA Mars, and then when I said RhoV, I would append open NASA Mars to the front of everything that it recorded after that, and I shipped the whole thing off to AWS. Yeah, don't say that too loudly outside of this room. So that was the original prototype, and it was okay. It came back in a few seconds. But then with the announcement of Amazon Lex, it's exactly the use case that we wanted to touch, right? It's one skill at a time, and everything is still built in the same programming model in the back, so we're very excited to move it around, and we were able to drag and drop from one to the other very quickly, and it's all the same brain in the back end anyway, so it's really fantastic and very powerful for us. I do want to take just a moment to bore you with the little architectural diagram that we have here. So what you're actually seeing, the bulk of the brain capacity, ironically, is in the body, not the head. So the body is listening to my voice input. It's doing some local audio detection via a Snowboy hot word listener, keyword detector. Excuse me. And so when it's detected that I've heard the word RhoV, now it's going into a listening mode where it's going to take the next section of audio until I stop talking and send that off to whatever voice service we're using, AWS or Lex. Once that happens, so you saw when I was speaking to it that the lights actually change when it's listening to me and all that kind of a thing. That's done with AWS IoT. So that's updated in real time as I'm asking a question. Once the question is ready to be shipped off, it gets shipped off to Amazon Lex. Today, last week, literally last week, it was AWS. The Lambda function is called in the exact same way that a skills kit would call your Lambda function. And then for the voice responses, like the questions, we would come back down, basically, it hits our database, our little service that gets the answer, Lambda returns the response, it goes back to the voice client and spit out the speaker on RhoV. If we're actually driving and initiating the driving or the following mode, my Lambda function publishes a message directly to AWS IoT, which then the wheels and the head are watching on. And as soon as I say, drive forward, turn left, or follow me, then it actually triggers, all of the wheels to do the corresponding actions on RhoV. And I just show the Mars question there, highlighted in red, so those are the only pieces. And then when you add the driving, it's a subtle difference, but that line basically from AWS IoT down to the listener and the wheel rovers, that actually happens. The use case is follow me, which you saw. And with that, I think we're going to start taking some questions.
So one
in a
point.
moment.
So you remember the suggestion skill that we're asking JPLX for suggestions? So that skill on RhoV now, when RhoV start talking to students in museums, all of a sudden we get skills from all over the world that we can then say, okay, or suggestions, we need to do this, this, and that. And that's part of the power of very low cost, and we can get all kinds of good information. So I think we're ready to take questions. If you have any questions.
Absolutely.